Have you ever looked up into the night sky? Far away from the bright lights of our cities, a vast darkness stretches out. It is filled with tiny, glittering points of light. We call them stars. For a very long time, this darkness was a great puzzle. People wondered, if the universe is endless and full of countless stars, why is the sky not a brilliant sheet of light? Surely, in every direction we look, our eyes should eventually find a star. The whole sky should be as bright as the sun. But it is not. Instead, we see a deep, profound blackness. This simple question holds a very deep and surprising answer. The puzzle of the dark night sky troubled thinkers for centuries. They imagined a universe that was infinite and unchanging. In such a place, every line of sight would end on the surface of a star. The combined light from all these stars, stretching out forever, should fill the sky completely. There should be no dark spaces at all. Yet, when we stand under the heavens, we are surrounded by an immense void. This contradiction, this simple observation that the night is dark, tells us something fundamental about the very nature of our cosmos. It is a clue, waiting to be understood. This darkness is not an absence of things, but a presence of a great story. It is a story about time and about distance. The blackness we see between the stars is not empty. It is a canvas on which the history of the universe is written. The solution to this old paradox is not found by looking for what is there, but by understanding what has happened over an immense stretch of time. The universe, it turns out, is not the static, eternal place we once thought it to be. It is alive, with change, and the dark sky is one of its most powerful messages to us. The silence of the night sky seems to suggest a calm, peaceful universe. But this is an illusion. The darkness is a veil. It hides a story of incredible energy and unimaginable scale. It speaks of a beginning and of a journey that is still unfolding. To understand why our sky is dark, we must travel back in time. We must go to the very start of everything. The answer is not in the space between the stars, but in the nature of space itself. It is a journey that will change how we see our place in the world and in the grand, dark theater of the cosmos. The first part of the answer came from looking not just at single stars, but at whole families of them. We call them galaxies. These are immense islands of stars, dust, and gas, floating in the cosmic ocean. For a long time, we thought they were just clouds within our own galaxy. But then, we built more powerful telescopes. We looked closer. We saw that these were entire universes of stars, just like our own Milky Way. And when we looked at them, we found something extraordinary. They were not standing still, they were moving. A new understanding began to dawn. Almost every galaxy we could see was rushing away from us. And the farther away a galaxy was, the faster it seemed to be moving. This was a truly revolutionary idea. It was as if the entire universe was expanding. Imagine baking a loaf of raisin bread. As the dough rises, all the raisins move away from each other. No single raisin is the center of the expansion. From the perspective of any one raisin, all the others appear to be moving away. This is what we were seeing in the cosmos. Every galaxy was moving away from every other galaxy. This discovery shattered the old idea of a static, unchanging universe. The cosmos was not a fixed and eternal stage. It was a dynamic, evolving place. The very fabric of space itself was stretching, carrying the galaxies along with it for the ride. This expansion was happening everywhere. It meant that in the past, the universe must have been smaller. All the galaxies, all the stars, all the matter and energy we see today must have been much closer together. The universe had a history, a story of change on the grandest scale imaginable. This motion, this grand cosmic expansion, is the first key to understanding the dark night sky. If galaxies are moving away from us, then the light they send out is affected. And if the universe is expanding, it suggests that it had a beginning. a moment in the distant past when everything was incredibly close together. The idea of a quiet, eternal cosmos was replaced by a far more dramatic story. It was the story of a universe born in an unimaginable flash, and growing ever since. The darkness we see is a direct consequence of this incredible, ongoing journey. If the universe is expanding today, then long ago, it must have been incredibly small. All the matter and energy that now fills the vastness of space would have been compressed into a point of unimaginable density and heat. This idea gave rise to a new theory of our origins. A theory of a single, explosive moment that started everything. We call it the Big Bang. It was not an explosion in space, like a bomb going off. It was the beginning of space itself, and the beginning of time. Before it, there was nothing we can comprehend. In the very first fractions of a second, the universe underwent a period of astonishingly rapid growth. This is known as cosmic inflation. In a moment too brief to measure, the universe swelled from something smaller than an atom to something larger than a galaxy. This incredible burst of expansion smoothed out the universe, making it incredibly uniform on the largest scales. It laid the foundation for the cosmos we see today, ensuring that matter would be spread out evenly enough to eventually form the great structures of galaxies and clusters of galaxies that we now observe. After this initial furious expansion, the universe continued to expand and cool, but at a more leisurely pace. It was a searingly hot soup of fundamental particles and energy. There were no atoms, no stars, no galaxies, just a brilliant glowing fog, hotter and brighter than the core of any star. For hundreds of thousands of years, this light was trapped, bouncing endlessly from particle to particle. The universe was completely opaque. An observer inside this early cosmos would have seen a blinding uniform white light in every single direction. This period of a hot, dense, and glowing universe is a critical piece of our story. The Big Bang Theory tells us that the universe did not exist forever. It had a starting point. This means the universe has a finite age. It has been around for a vast, but not infinite amount of time. This fact, that time itself had a beginning, is one of the most profound discoveries in human history. It sets a limit on how far we can see, and it helps explain why the night sky is not ablaze with the light of an infinite number of stars. The story of creation was no longer a myth, but a scientific reality. For a long time, the idea of a hot, early universe was just a theory, a compelling story, but one without direct proof. If the Big Bang really happened, there should be some leftover heat, some afterglow from that initial fireball. Scientists calculated that as the universe expanded and cooled over billions of years, this primordial light would have cooled as well. It would no longer be visible as brilliant white light. Instead, it would now exist as a faint, cold glow of microwave radiation, invisible to our eyes but detectable with the right instruments. And then, it was found, entirely by accident. Two scientists trying to build a better radio antenna found a persistent, faint hiss in their equipment. No matter where they pointed their antenna, the noise was there. It came from every direction in the sky, day and night, with the same intensity. They had discovered the echo of creation. This faint microwave hiss was the oldest light in the universe. It was the afterglow of the Big Bang, a relic from a time when the entire cosmos was a glowing furnace. We call it the cosmic microwave background. This discovery was one of the most important in the history of science. It was the photographic evidence of the Big Bang. It was a baby picture of the universe, taken when it was just a few 100,000 years old. At that point, the universe had cooled enough for the first atoms to form. Light was finally set free, and it has been traveling across the cosmos ever since. The cosmic microwave background radiation has been journeying through space for billions of years, and today, it washes over everything, including our own planet. This ancient light provides a powerful answer to the puzzle of the dark night. It tells us the universe had a beginning. There was a time before which stars did not exist. Therefore, the light from the very first stars has had only a finite amount of time to travel towards us. We cannot see stars that are so far away that their light has not yet had time to reach us since the beginning of the universe. The cosmos is vast, but our view of it is limited by its age. The darkness is there because the story of starlight has a beginning. But the age of the universe is only part of the story. The expansion of space itself has another, equally profound effect on the light traveling through it. As light journeys across the expanding cosmos, the very waves of light are stretched. Imagine a wave drawn on a rubber sheet. As you stretch the sheet, the wave gets longer and flatter. The same thing happens to light in our expanding universe. Light that was emitted from a distant galaxy as blue or white light gets stretched out as it travels through space. This stretching of light is called redshift. It shifts the light towards the red end of the spectrum, where the wavelengths are longer. If a galaxy is very far away and moving away from us very quickly, its light will be stretched a great deal. The light can be redshifted so much that it moves beyond the red light that our eyes can see. It can become infrared light, or microwaves, or even radio waves. All of these are forms of light, but our eyes are not built to detect them. We are blind to this deeply redshifted light from the most distant objects. So even if the light from a very distant star has had enough time to reach us, the expansion of the universe may have stretched it so much that it has become invisible to us. The star is still shining, and its light is still arriving here on Earth, but it arrives as a form of light we cannot perceive. The energy is there, but our eyes simply cannot register it. The universe is filled with this invisible light, a silent testament to the vast distances and incredible speeds involved in the cosmic expansion. This provides the second, crucial part of the solution to the dark sky paradox. The night sky is dark not only because the universe has a finite age, but also because the expansion of space itself steals the energy from the light of distant galaxies. It stretches the light into invisibility. The universe could be filled with countless brilliant galaxies beyond what we can see, but their light is so redshifted by the time it reaches us that it contributes no brightness to our visible night sky. The darkness is a story of stretched light and the limits of our own senses. Because the universe has a finite age and is expanding, there is a horizon to what we can see. This is what we call the edge of the observable universe. But, it's not a physical wall or any kind of edge to space itself. Instead, it's really a boundary in time. We just can't see anything beyond this horizon because the light from those regions hasn't had enough time to reach us since the Big Bang. The observable universe is a sphere with us right at the center, encompassing everything whose light has had a chance to travel to Earth over the last 13 billion years. Now, what lies beyond this horizon? Honestly, we don't know for sure, but according to our best theories, the universe doesn't simply end there. Space itself likely continues, maybe even forever. Beyond our horizon, there are probably more galaxies, more stars, and more planets, stretching on and on. There could even be an infinite number of them. But we'll never see them. They're beyond our cosmic horizon, their light lost to us for all time. It's a humbling thing to realize, being surrounded by a universe so much larger than we can ever hope to witness. And the expansion of the universe is also accelerating. It's getting faster and faster as time goes by. This means that galaxies currently visible to us, those near the edge of our observable universe, will one day be carried away from us so quickly that their light will no longer be able to reach us. They'll cross our cosmic horizon and disappear from our view forever. The sphere of our observable universe contains a finite number of galaxies, and as time goes on, that number will actually decrease. We're watching as parts of our universe slowly fade from sight. This concept of a visible universe, a bubble of light in an ever-expanding space, is really the complete answer to that old paradox. The night sky is dark because the universe isn't infinitely old, and because the expansion of space redshifts light out of our visible range. And beyond what we can see, there's a vast, unknown cosmos that will forever remain a mystery. We're like sailors on a small boat in the middle of a vast ocean, able to see only to the horizon but aware that a much greater world exists just beyond our perception. Let's now travel far into the future, trillions of years from now. The expansion of the universe will have continued, relentlessly. The acceleration will have carried almost all the galaxies beyond our cosmic horizon. Imagine, for a moment, an astronomer in this distant future. They would look out into the cosmos with telescopes far more powerful than anything we have today. And honestly, they would see almost nothing. Our own galaxy, the Milky Way, will have merged with its nearest neighbors to form one giant super galaxy. But beyond that, just emptiness. The night sky for these future observers will be a truly dark place. They'll see the stars of their own galaxy, a magnificent spectacle of local lights. But the great cosmic sea of other galaxies will be gone. The light from those distant island universes will have been so redshifted by the cosmic expansion that it's completely undetectable. The faint afterglow of the Big Bang, the cosmic microwave background, will have stretched and cooled into oblivion. It'll be so faint that it would be impossible to ever discover it. These future astronomers would be living in a universe that appears static and empty. They'd have no evidence of the Big Bang. They'd have no way of knowing that the universe was expanding. They might conclude quite logically that their single giant galaxy was the entire universe. All the clues that we have today, the redshift of distant galaxies, the cosmic microwave background, will have been erased by the passage of time and the relentless stretching of space. The true nature and history of the cosmos would be forever hidden from them. The story of the universe would be lost. The grand narrative of a fiery birth, of cosmic expansion, and of a universe filled with 100 billion galaxies would be an undiscoverable secret. They would be trapped in a kind of cosmic bubble of ignorance, unaware of the true grand scale of reality. Their vision of the cosmos would be as incomplete as the vision of ancient people who believed the Earth was the center of everything. They'd live in a profoundly lonely universe, unaware that they were the descendants of a much richer and more connected cosmic age. This journey into the distant future reveals something pretty remarkable about our own time. We're living in a very special moment in the history of the universe. We're here at a time when the sky is not yet empty. We can still see the evidence of the Big Bang. We can still measure the expansion of space. We're fortunate enough to be able to piece together the entire cosmic story, from its first moments to its potential future. This is a privilege that just won't last forever. It's a fleeting window of opportunity. We live in a golden age of cosmology. We have the tools and the perspective to look back in time, all the way to the dawn of creation. The cosmic microwave background is still detectable. The distant galaxies are still visible, their light carrying the secrets of cosmic expansion. Just a few billion years from now, this evidence will begin to fade. We're perched on a cosmic precipice, able to see the past and contemplate the future, in a way that will be impossible for any beings who may come after us in the far, far future. It's really a matter of pure chance that we exist in this particular epoch. Life on Earth emerged at just the right time for intelligent beings to develop and look up at the sky, and for that sky to be filled with clues about its own origin. We are the generation that can see the distant shores of the cosmic ocean. We can map the galaxies, listen to the echoes of the Big Bang, and understand the grand narrative. It's almost as if the universe has waited for us to arrive, to witness its story before the evidence is swept away by the cosmic tide. So when you look up at the dark night sky, remember this: the darkness is not an emptiness. It's a story. It is the story of a universe that had a beginning, that is expanding, and that is slowly, over eons, fading from view. We are incredibly fortunate to be here now, to be the ones who can read that story in the light of distant stars and ancient radiation. It's a profound and humbling position to be in, to be the universe's conscious witnesses to its own magnificent, unfolding drama. There's one last simple puzzle about darkness that often causes confusion. We've all seen photographs taken by astronauts, maybe standing on the moon. In these pictures, the sky above them is completely black. There are no stars to be seen. Why is this? If there's no atmosphere to obscure the view, shouldn't the sky be filled with the brightest, sharpest stars imaginable? The answer really has to do with light, and how our cameras, and our eyes, work. It's a matter of brightness and contrast. Imagine you're in a dark room and someone lights a single candle. Your eyes will adjust, and you'll be able to see the faint details of the room around you. But if someone then turns on a very bright spotlight and points it at you, everything else will disappear into blackness. Your eyes will adjust to the bright light, and they'll no longer be sensitive enough to see the faint candlelight or the details in the shadows. The bright light overwhelms your ability to see the dim light. This is exactly what happens in photographs taken on the moon. The surface of the moon, lit by the direct, unfiltered sun, is incredibly bright. The astronauts' white spacesuits are also dazzlingly bright. To take a clear picture of the astronaut and the lunar landscape, the camera must be set for a very short exposure. It lets in only a tiny amount of light. This is enough to capture the bright surface. But it's not nearly enough time to capture the faint, distant light of the stars. The stars are there, but they're just too dim to show up in a photograph set to capture something so brilliant. If an astronaut on the moon were to stand in the shadow of their lunar lander and allow their eyes to adjust to the darkness for several minutes, the stars would appear. And honestly, they'd be spectacular. Unblinking, incredibly sharp points of light against a perfect black. They don't twinkle because there's no atmosphere to disturb their light, but in the presence of the blinding sun and its reflection off the lunar soil, the faint stars are simply washed out, invisible to both camera and eye. The blackness of space in these photos isn't an absence of stars, but a testament to the overwhelming brightness of our own.